Okay, we're looking at lesson 1-5, solving inequalities. And it says, for essential understanding, just as you use properties of equality to solve equations, you can use properties of inequalities to solve inequalities. So an inequality, x greater than 4 is x greater than 4. And we have x greater than 4. Notice the open sentence because it's not equal to 4. Then we have x greater than or equal to 4. And here we have the closed dot. And here we have x is less than 4. So we have the open circle because it's not equal to. And I'm going and to the left. And x is less than or equal to 4. Again, my closed dot. So in the graphs above, the point 4 is a boundary point because it separates the graph of the inequality from the rest of the number line. An open dot for 4 means it is not a solution. A closed dot at 4 means it is a solution. Alright, so let's look at problem number 1. It says, what inequality represents the sentence 5 fewer than a number is at least 12? So I have 5 fewer than a number. So that means I'm going to be subtracting. So I have x minus 5. So it's 5 fewer than a number. And then it says at least 12. So that means that this value here, the least amount that it can be is 12. So it has to be greater than or equal to 12. Let's look at guidance number 1. It says what inequality represents the sentence the quotient of a number and 3. So we have the quotient of a number and 3. Then it says is no more than 15. Therefore, if it's no more, that means that 15 is the absolute greatest number that it can be. So it has to be less than or equal to 15. I hope this helps.